Last type of function we're going to look at is the piecewise function and the step function, otherwise known as the greatest integer function. The piecewise function is based on the idea that a piece of the graph is doing one thing and the other piece of the graph is doing another thing. And what I've done, I've drawn a vertical line through x equals -1, and that's this green line right here. And that divides our graph into two parts, and what happens on the left is different than what happens on the right of that green line. On the left of that green line, I want to draw the line f of x, or y, equals -x, and that's this line right here. And since it's less than -1, I've drawn an open circle here. When x's are smaller than -1, it's going to be a solution that's up here. When x's are greater than or equal to -1, which should be on the right side of this green line, I have the line f of x equals x, or y equals x, and that's this line right here. Notice that they go on forever and ever in those two directions. And since this is greater than or equal to, I have a closed dot here at -1. And then we can plug in some values, and we can do it a couple of ways. We can just look at the graph. What is happening when f is equal to -2, or when x is equal to -2? Well, when x is equal to -2, y is equal to 2. When f of x equals -1, and that's on this line, all right, when f of x is equal to -1, y is equal to -1. And notice it's not equal to 1, it's down here, because this is the closed dot. And then when f of 1 is found, it's located here at 1. When x is equal to 1, y is equal to 1 also. Another example here, this is a combination of a line and a parabola, a quadratic equation here, when x is less than 1 and greater than or equal to 1. So I've drawn a green line here to sort of show where the graph separates itself. I've actually had to add a couple of little points down here to make sure my graph, you can find the missing point here, -9. Anyway, when x is less than 1, f of x, or y, will equal 6, and that's a horizontal line going through 6. And you can see, of course, we got the arrow going in that direction, and since it's less than 1, we have an open circle there. When x is greater than or equal to 1, I've graphed the line negative parentheses x minus 4 squared, and that's this parabola right here. And it goes through the point 0, 4, and over 1 down 1, over 1 down 3, over 1 down 5. And oh boy, that should be a pattern that you're familiar with. Over 1, down 1, over 1, down 3, over 1, and this would be down 5. It'd be down here somewhere. So when f of -2 will equal 6, and here it is, f of -2. Here's -2 on the x-axis, and if I go up and meet here at the y, at the graph, it equals 6. F of 1 equals -9. Here's -1. Here's 1, and it is y value is -9. And notice again, that's a closed dot, so that's the solution, not 6. And f of 3 equals 1. Here's 1, 2, 3, and it equals -1. The other way to go about this is to plug the values in. All right, I can very simply plug in -2. Now the question is, which one do I plug it into? Do I plug it into the top equation or the bottom equation? Well, -2 is less than 1, so y will equal 6. And f of 1 equals -9. That's going to be the equal sign here, and 1 minus 4 is -3. -3 squared is 9, and the opposite of that is -9. And of course, if I plug in 3 minus 4 is -1. -1 squared is 1, and the opposite of that is -1. Next function is the greatest integer function, and essentially it's the greatest integer that you have just passed as you go from left to right on the number line. So the greatest integer that you pass as you go from left to right, closest to negative 231, of course, would be negative 231. And as you're going to left to right on a graph, you would come to negative 3, and then you get to negative 2.56. So the last integer that was passed going from left to right would be negative 3. And here you would go past 5, and then you get to 5.28. So the greatest integer just passed is 5. And again, just to demonstrate that this is not a rounding exercise, the greatest integer that I pass as I go through the number line would be 3, and then I'd get to 3.506. And so the greatest integer that I've just passed is 3. And it's called a step function, and I'm going to help you set up the graph, the TI-83, so it'll graph that, and you're going to use this function right here. You're going to use this setup. You're going to go to mode and go down a few, and then you'll see dot on the right, and click on the dot, or move the cursor to the dot and hit enter so that the dot is then solid. And then you can type in any equation, and to do that we're going to do y equals, and then we'll hit the math button, then we'll arrow to the right and get to the number, and then if you look down you'll see the int, and that's integer. And so it's going to find the integer that you've just passed on the number line, and you'll see the graph here in a second for the greatest integer closest to x. And here is that function again, the greatest integer, that's the double brackets right here, greatest integer closest to x. And you can see this is why it's called a step function. As I go from left to right, it jumps up when it gets to the next integer. It goes along, jumps up when it gets to the next integer. It goes along. And so our example of negative 2.56, all right, is right here. Here's negative 3, and then I would get to negative 2.56. And then I would go along and I would jump up. So here's negative 3, go along, negative 2.56. I jump up at negative 2. And I think we had 5.28. So 1, 2, 3, 4, 5, and move along 5.28. And I wouldn't jump up to the next number until I get to 6. And 3.506, here's 3, 3, 3, 3.506, 3, 3, 3, and it jumps up at 4. And to demonstrate that you can shift these functions, if I subtract 2 inside the brackets, the greatest integer brackets, it drops it down 2. That is actually what it seems like. And you can see shifting it to the right wouldn't do anything except for actually make it go down. So it's the same function. So really this point that would be right here has been shifted down 2 from where it would be right here, and down 2 from here, down 2 from here, like that. So we've subtracted 2 and we've shifted the whole graph down 2. And as always, if you have any questions or if there's anything I can help you with further, please post in Edmodo and let me know that you've watched the video, and if you understand it or if there's some questions that you have, please ask them. It's very helpful to be able to modify my instruction on Monday if I know what questions that you're going to have. Thank you, and hope the rest of your weekend goes well.